Here are examples of the flownet problems that were assigned for homework. These have been worked out by hand and were scanned to give you an idea about what we were looking for. These are the criteria that we used to grade the work. The ratio along the stream tubes needed to remain barely constant within an acceptable tolerance. The streamlines and the equipotentials needed to be perpendicular to each other, and they should be perpendicular where they intersect the boundaries. And there should be no abrupt kinks in either the flow lines or the equipotentials. So here's this problem of this is a stream, and this is a well, and this is the flow patterns that would go to this well. And you can see, if you follow the stream tube along, that the ratio, which I'm showing here with these crosses, is roughly 1:1, and it's maintained along that stream tube. Here the ratio is a bit more elongate, but as you follow it along here, it's maintained. We also see that the equipotentials here kind of wrap around, and where they intersect the no flow boundaries, they're perpendicular. All of the streamlines start at a constant head boundary. Here, this one that's representing the stream, and they end at a constant head boundary. So that's the case up here. This is the constant head, and this is the other one. So these are the streamlines, and flow is going along that pattern. And you can see that the ratio is maintained along these stream tubes, and everything is perpendicular where it intersects. This is the well on the island problem, and this is very symmetric. This is really fairly straightforward to do, so long as you do this. You need to make sure that this ratio is maintained along the stream tube. And so what that means is that as you go in towards the center, the spacing between the equipotentials needs to decrease to maintain a constant ratio. And so as you get closer and closer, the spacing between the equipotentials gets closer, and what that means is that the gradient is steepening as you get closer to this well at the center of the island. Here are the other flow nets. I don't think you had to do this one, but it's an example of another flow net worked out. This was the one that we did in class, and here again I use these crosses to indicate the ratio, and I go along and check the ratio. And here, this one looked like it might be a little bit too wide this way compared to that, so if I wanted to continue working on this, I might bring it in a little bit, but it's okay within the tolerances for just doing these things by hand. Also, drew in these perpendicular symbols just to indicate that these lines are indeed perpendicular. You can see this equipotential comes in, and as it gets close to this no flow boundary, it curves and matches up, intersects the no flow boundary with a perpendicular orientation.